Okay, so in this video I'm going to have a look at the area and perimeter of this compound shape here. So this particular shape here is made up of various rectangles and triangles all stuck together. So it's this shape here, from here down to here, across, up. It's this shape here, okay? Not these, doesn't include these dotted lined areas here. So I'm going to work out the area first. Now, the area of this shape here can be worked out a couple of different ways, and I'm going to do it both ways. So the first thing I'm going to do is work it out by, first of all, working out the area of this rectangle here. So I'm going to just join this up here. And you can see you've got this rectangle, this big rectangle here. And I'm going to subtract this area here and this triangle here as well. So the area of our rectangle is just going to be length times width. In our particular case, we've got a length of this 13 plus this 3 here, so it's going to be 16, and we've got to multiply that by 8. When you do that, you get 128 centimeters squared. So the area of our entire rectangle here is 128 square centimeters. Now we've got to subtract this triangle here, and we've got to subtract this shape here. This shape here, by the way, is made up of a triangle, right angle triangle here, and this rectangle here as well. Now our rectangle here is going to be made up of, there should actually be another dimension in here. This is actually 5 centimeters here, which I didn't put it in at the beginning, but this is 5 centimeters down along here. So this rectangle here is going to have dimensions 5 by 7. Our triangle here, it's also going to have a height here of 5 centimeters, but we don't have this dimension here. Now this dimension here is just going to be, it's just going to be all of this, and then we've got to subtract these horizontal dimensions here. So in other words, the entire distance from here right over to here is going to be 16 centimeters. In other words, it's the same distance as it is from here to here, which is 3 plus 13, which is 16 centimeters. So we've got to take 16 centimeters. We're going to take 16 centimeters, and we're going to subtract this 4, plus we're going to subtract this 7, and then we're going to add this 2 centimeters and subtract it. So it's going to be 16 centimeters minus the 4 minus the 7 minus this 2. So that will just give us 16 minus 7, 8, 10, 11, 12, 13. So that's just going to give us 3 centimeters here. So this dimension here then is just going to be 3 centimeters. Okay, so I think we have everything now that we need to work out our area. So first thing we're going to do is just take, so we'll write it down in full anyway. So our area then is just going to be equal to, 128 centimeters, and then we're going to subtract these 3 dimensions here. We're going to subtract this triangle here. So a triangle's area is half the base times the height, so it's just going to be half of 3 times 8. Remember, this is 8 centimeters up along here as well, because this is 8 centimeters here. So we've got to subtract that. We've also got to subtract this rectangle here, which is just simply length times width, which is 7 times 5. That's going to be 7 times 5. And then we've also got to subtract this triangle here, half the base times the height again, so it's just going to be half times 3 times 5. So the reason I put in these big brackets here is because we were adding these 3 dimensions up, and they're all going to be added and then eventually subtracted from 128. So what happens if we do this? Let me just move up a little bit here and work this out. So we've got 128 here, and we've got to subtract. So we're going to subtract half of 3 times 8. Well, 3 eighths 24. Half of 24 is 12. We've got to subtract also this 5 sevenths, which is 35. And then we've got half of 3 times 5. Well, 3 5 is 15. Half of 15 is 7. 0.5. So we've got 128 here minus, we've got to add these three up. Well, we've got 35, 45, 47. That'll give me 54.5. And if we subtract that, we get 73.5 centimeters squared. Okay, so that's the area of our shape. That's probably the quickest way of doing it. Now, I'm going to do it another way as well. What I'm going to do is I'm just going to take the shape itself and I'm going to break it up into different triangles and rectangles and just add up the areas of each. So I'm going to take, for example, this triangle here. This triangle here has dimensions 8 centimeters up along this way, and this distance here is just going to be the same as this distance here, which is 3 centimeters. So I have the dimensions of this triangle here. I've got a rectangle here, so the rectangle here has dimensions 8 by, well, if this is 3 and this is 4, this must be 1 centimeter here. So this rectangle here has dimensions 8 by 1. We have another rectangle here. The dimensions here are going to be 7 times this distance here. Well, let's see if we can work that out. Well, from here to here is 5. From here to here is 8. So 8 minus 5 will give us 3. This must be 3 centimeters here. So now I have the dimensions of this this rectangle here. Now let's see. Here we have 3 different shapes. We have a rectangle along here. So this one here. This is going to be 3 centimeters here. And along here then we've got the same as this distance here. We have 2 plus 3. So this is going to be 5 centimeters along here. It's the same as this distance here. Up here we have a rectangle and a triangle, so let's see if we can break that down. So we have this rectangle here, which is just going to be 2 times 5. We know that this is 5 centimeters here, so this must be 5 centimeters here. Okay, so we're just left with this triangle here. Now let me see. This is actually the same size as this triangle here. So this is going to be 5 here, 5 centimeters, and along here then, this distance is going to be the same as this distance here, which is 3 centimeters. Okay, so I have the dimensions of all these different rectangles and triangles here. So let's just add them all up. Okay, so first of all, we've got this triangle here. Let's start here. So this is going to be half of 3 times 5, half the base times the height, half of 3 times, not 5 but 8, half of 3 times 8. So let me just write all this down here. So now we're working out the area again a different way. So let me just do that in white. So we have area is going to be equal to half of 3 times 8. That's our first one. Okay, let's move back up again and see what we have. We have 8 times 1. That's this rectangle here. So 8 times 1. So here we've got 8 times 1. Let's do the next one now. So we have this rectangle here. That's going to be 7 times 3. Length times width. 7 times 3. So let's do that one. That's 7 times 3. Now we've got, well, let's do this rectangle here. That's 5 times 3. 5 times 3 here. That's 5 times 3. Now let's see what else we have. Okay, we've just these two shapes here. We've got a triangle and a rectangle. So this is half of 3 times 5, half the base times the height for this triangle here. Half of 3 times 5. This is going to be half of 3 times 5. And then finally we have this rectangle here, which is 5 times 2. 5, it's 5 this way and it's 2 this way, so it's 5 times 2. So let's just finish that off. 5 times 2. Okay, so let's add these up, and we should end up with 73.5, hopefully. So here we have half of 3 times 8, so that's going to be 3 8s, 24. Half of 24 is 12. Here we have 8 times 1, which is 8. Here we have 7 times 3, which is 21. We have 5 times 3, which is 15. We have half of 3 times 5. Well, 3 5s 15. Half of 15, 7.5. And then finally 5 times 2, which is 10. Okay, hopefully this will add up to 73.5. Let's see. Here we have 12 plus 8, which is 20. 20 plus 21 is 41. This will give us 56. 66 if we add the 10, and then 73.5. Yeah, that works. 73.5 centimeters squared. So we do get the same answer in both cases, so that's perfect. Okay, so the next thing I'm going to do is work out the perimeter of this shape. Now, the perimeter, I'm going to start here. So let's say, do this in green, let's say, okay. So I'm going to start here. So we'll call this number 1 here, and I'm going to work down here to number 2, work way across here to number 3, up here to number 4, here to number 5, down here to number 6, 7, 8, and then back to 1 again. So that's the this is the route I'm going to take here. 1, 2, 3, 4, 5, 6, 7, 8, and back here to 1. So let's work out these distances. Now from 1 to 2, we don't have that distance. But if we look at it, we see we do have a right angle triangle here. We have this right angle triangle here. Now, so we have an 8 here, we have a 3 here, and we got to work out what this is here. So let me just do that down here. 8, 3, and something else. So we're going to start with, we're going to do a perimeter. So we've got to add up a lot of lengths here. So to start this off anyway, we have this right angle triangle, which looks like this. We know that that's 8 centimeters. We know this is 3 centimeters, and we got to work this out here. We'll call it x centimeters here. This is right angle here. So we're going to use Pythagoras Theorem here. So we know that 8 squared plus 3 squared will give us our x squared here. So our x squared is going to be 8 8s 64, 3 3s 9, so we end up with 64, 73. 73, or x squared is 73. So what we need to do here is get in order to go from x squared to x, you square root both sides. So the square root of x squared is x. The square root of 73. The square root of 73 is 8.544. So 8.544 centimeters. Now I've rounded this to 3 decimal places. So it's going to vary from question to question. If they ask you to round it to 3 decimal places, then you've got to make sure that this is more than 3 decimal places. You never round till the very end. So I'm going to assume here that we want the perimeter rounded to 1 decimal place. So I've rounded this to 3 decimal places. If I round this to 1 decimal place, at this stage I'm starting to introduce errors. So you wouldn't round until the very end. Okay, so our first length here anyway is 8.544 centimeters. Okay, so let's move on then. We've got this distance down here, and I know that that's 8.544 centimeters. Okay, so now we want to go from here to here, from 2 to 3, so that's 13, up to 4, which is 8, and across here to number 5 here, which is 2. So it's 13 plus 8 plus 2. 13 plus 8 plus 2. So let me just write those in. It's going to be 13 plus 8 plus 2. Okay, now let's see what we have to do next. Okay, so next thing we're going to do, we're at number 5 here, so we're going to go down to corner number 6. So again here we don't have this distance. However, we do have a right angle triangle here with dimensions 3 and 5. So we're going to do the same thing again. Use Pythagoras Theorem to work this out. So let's do that down here. So we have a triangle that looks something like this. And we have 3 centimeters here, 5 centimeters here, and we want to work out, let's say, y in this particular case. So here we know that we have 3 squared plus 5 squared is equal to y squared. So that will give us 9 plus 25 is equal to y squared. That will give us 34 is equal to y squared. So we want to get the square root of y squared, which is y. Get the square root of 34. Again, I've just rounded that to 3 decimal places. So that's going to be 5.831 centimeters. 5.831. So I'm going to put that in here. 5.831. Okay, so let's move on again. So where are we now? We're down here at number 6. So now we got to go across here to number 7. So that's 7 centimeters here, 5 centimeters up here, and 4. So it's 7 plus 5 plus 4. 7 plus 5 plus 4. So it's 7 plus 5 plus 4. Okay, so we got to just add all of these up. If you add all of those up, you get 53.4. It's going to be 53.4 centimeters. So this here is the perimeter of the shape. It's what distance you have to walk, if you like. If you walked from here down to here, across, up, and then back to here again, you would walk 53.4 centimeters. Okay, and that's it for this particular video.